The jumper.
Nearly 3 decades of development. Over $100 million spent. Cars sold to the public. None. Not a handful. None. This is Project Sound, and it was built by Bose.
Yes, that Bose.
The speaker company spent the better part of 30 years quietly trying to fix the car. No spring. No damper either. At each corner, there is a linear electromagnetic motor doing the whole job electrically. Sensors read the road, and the motor shoves that one wheel up or down on its own, so the body just stays where it is. Corners, braking, potholes, it does not care. On the far side of a bump, the motor runs backwards as a generator and pushes the power back into the system. Then there's the party trick. Give it a low wall and the car hops over it. Bose were clear that this was never meant for a production car. They built it because they could. So why can you not buy one? Too heavy and weight is fuel economy, and fuel economy in America is the law. And staggeringly expensive. Amar Bose said himself it only suited luxury cars. Not one manufacturer took it. In 2017, the prototypes and patents went to a startup called Clear Motion, who built their own electro-hydraulic version instead. 30 years and nobody wanted the magnets. The sinker. Your brand new Cadillac is lying on the drive with its frame in the gravel. It failed suddenly and without warning. 1957. General Motors decided steel springs were finished and replaced them with air. The Cadillac Eldorado Brougham got it as standard equipment. An engine-driven compressor feeds reservoirs. The reservoirs feed a rubber bellows at each wheel, and each one is called an air dome. Sensors watch the road and the load and pump the car back to the right height on their own. Put 4 adults in the luggage in a 50s Cadillac and it does not squat at the back at all. Here's the problem. It leaked. Not in one place at every fitting and every control point in the system, and in cold states it froze up as well. When air suspension loses its air, it does not limp. The car settles all the way down onto its own frame and it will not move. You have to tow it off the drive. Owners worked out it was cheaper to rip the whole thing out and fit ordinary coil springs. Within 2 years, the dealers were selling them the kits, and eventually Cadillac released a factory conversion of its own. Air suspension then vanished from American cars until 1984. The cure was sold by the people who caused it. The long bar. A steel bar down each side of the car, nearly as long as the car itself, and the springing is done by twisting it. This is Packard torsion level 1955 standard on every senior Packard. Each bar ties that side's front suspension straight to its rear, so when the front wheel rides up over a bump, the movement is fed backwards through the chassis, and the back of the car is told about it before it gets there. The car stops pitching. In 1955, nothing built in America rode like it. Then there's the clever bit bolted onto the clever bit. 2 extra short torsion bars, 46 inches on the cheaper cars and 51 on the expensive ones, connect the rear end to an electric levelizer. Load the boot, wait about 7 seconds, and a motor winds twist into those short bars and lifts the back of the car level again. The motor burned out, often enough that dealers started quietly wiring in a cutout switch so the leveling only ran when the owner asked for it. The rubber bushings at the back perished, and once they went the ride height, the leveling and the handling went with them. Then the real killer arrived, and it had nothing to do with suspension. Packard was dying. After the Studebaker merger, the proper Packard stopped in 1956. Best ride in America.
Wrong company.
The tire pressure fix. The engineers asked for an anti-roll bar. Management said it cost too much, so the handling of the car was handed over to your tire pressures instead. This is the Chevrolet Corvair. Engine at the back and swing axles at the back with it. A swing axle is a half shaft hinged near the middle of the car, so as the body rolls, the wheel on the end of it swings through a big change in camber. Lean on it hard in a corner and the outside rear wheel tucks under. The tread peels off the road. The back lets go, and you're facing the wrong way. The fix they used instead of the bar was tire pressure. Run the fronts soft, and the rears hard, and the car understeers. And understeer is safe. It genuinely works. Right up until any owner or any garage or any bored forecourt attendant puts a normal amount of air in the front tires, at which point the oversteer comes straight back. The soft fronts also ate into what those tires could safely carry. Over 100 lawsuits were pending against General Motors. In 1965, Ralph Nader called it the leading candidate for the unsafest car title, and the noise helped push the National Traffic and Motor Vehicle Safety Act through the year after. General Motors had already given up and fitted a fully independent rear end for 65, with half axles that hold constant camber whatever the body does. Then in 1972, 3 years after the last Corvair was built, the government took a swing axle car, tested it against a Falcon, a Valiant, a Beetle, and a Dauphine, and found it compared favorably, with no abnormal tendency to lose control or roll over. Exonerated 3 years after the funeral. The sealed can. Your entire front suspension is sealed inside a tin can full of oil. You cannot see into it, and you cannot rebuild it. It was invented by André Dubanet, a French engineer who inherited the Dubanet vermouth fortune and spent it on engineering. He bolted the first one to his own Hispano-Suiza in 1933. General Motors licensed it, filed it under the knee action banner. It was slapping on every new independent front suspension that year and put it on every Pontiac and every Chevrolet Master from 1934. It is a leading arm design. A solid beam carries a kingpin at each end. The suspension arm swings around that kingpin, and the wheel hangs outboard on a stub axle. Inside the sealed housing there are 2 coil springs, one inside the other, and a double-acting hydraulic damper, the top cylinder catching the bump and the bottom cylinder catching the rebound. The steering gear sits inboard, so the unsprung weight is very low. On paper, this is well ahead of what everyone else was bolting on, and all of it depends on one seal, down at the bottom where the pivot arm comes out of the housing. That seal perished. The oil ran out. A double-acting damper with no oil in it does not damp anything at all, so the front of your Chevrolet turns into a pogo stick. Chevrolet's answer was to tell owners to keep checking the oil level in it, which is a maintenance habit no American driver has ever had. Pontiac gave up in 37. Chevrolet held on to 39. One perished seal took the whole front end. The kneeling car. Start the engine, and the car stands up. Switch it off, and it kneels back down again, slowly like something alive. This is the Citroen DS 1955, and it runs on nitrogen gas and hydraulic fluid. At each corner, there is a steel sphere with a flexible rubber membrane across the middle of it. Above the membrane, nitrogen and that gas is the spring. Below it, hydraulic fluid connected down to the wheel. An engine-driven pump holds the main circuit at 150 to 180 bar, comfortably over 2,000 pounds per square inch, and the nitrogen in the spheres sits at up to 75 bar. Height corrector valves add fluid when you load the car and let it back out when you unload it, so the ride height never changes whatever you put in the boot, and the driver can wind the whole car up on its toes to cross a field. So how did it die? It did not. That is the point of this one. Getting on for 9 million Citroens were built on it. Rolls-Royce and BMW and Maserati all licensed it, and it lasted 63 years. Then PSA looked at what it cost to build, killed it with the C5 in 2017, and fitted steel springs. Nearly 9 million cars, beaten by a spreadsheet. The rubber one. 51 cars were ever built. Between them, they carry 4 completely different suspension designs. They were still redesigning it while they were building them. This is the Tucker 48, and it rides on rubber. Firestone cooked up a special vulcanizing process to get blocks of rubber to behave at exactly the right rate. Watch them try to make it work. The prototype used 2 rubber discs at each end, too weak to hold up a passenger car. The next 2 cars got a rubber torsion tube, which developed severe toe-in under heavy braking, meaning the front wheels turned inward every time the driver hit the brakes. On those same 2, you could not take a rear wheel off without pulling the fender off first. Cars 3 to 25 got a rubber sandwich, a block squashed between the A arms, so stiff the car would lift a front wheel clean off the ground on a bad surface. Car 26 finally got a modified torsion tube that corrected the toe-in, and then none of it mattered, because the suspension is not what killed the Tucker. Selling accessories to customers before the cars existed brought the Securities and Exchange Commission down on them, and the investigation finished the company on March 3, 1949. The charges did not arrive until 3 months after that. A jury acquitted Preston Tucker on all counts in January 1950, 10 months after the company he was defending had stopped existing. 4 suspensions and a verdict nobody could spend. The plumbing. The front wheel and the back wheel on the same side of your car are joined together by a pipe. hit a bump at the front and the back of the car rises to meet it. This is Hydrolastic, invented by the British rubber engineer Alex Moulton with Alec Isagonis at BMC. They had both been staring at the Citroen and decided they could get the same ride out of something far simpler. Each corner has a sealed unit with fluid in it and a rubber spring inside it. There is no separate damper at all. The damping comes from squeezing that fluid through rubber valves. Now run a pipe from the front unit to the rear unit on that side. The front wheel hits a pothole. Fluid is pushed down the pipe. The rear unit pushes its wheel down, and the back of the car lifts to match the front instead of dropping away from it. The car pitches far less than something that short has any right to. It went into the Morris 1100, the Mini, the Big Austins, and from 1973 with nitrogen in place of the rubber, the Allegro, the Metro, and the MG. So what finally killed 40 years of it? A supplier put the price up. BTR raised the cost of the units enough that Rover simply stopped using them. The MGF was the last car on Earth built with it. Rover did the sums and stopped answering the phone. The band won 10 wins out of 16 races, a world championship, and then the sport made it illegal. It starts badly. The Lotus 92, Colin Chapman's last big idea, turned up in 1983 with a computer running the suspension. Hydraulic failures and glitches in the computer signals made the handling unpredictable. Nigel Mansell openly hated the thing, and after 2 races, Lotus put the concept back in the cupboard. Here's what it actually does. Take away the springs. Put a hydraulic actuator at each corner, wire up sensors, and let software decide the ride height and the attitude of the car many times a second. Nearly 10 years later, Williams got it right with the FW14B, built by Frank Durney out of Road Car Work. And the reason it was so quick is not comfort, it is aerodynamics. An F1 floor makes its best downforce in a narrow band of ride height, and normally the car is diving and rolling and squatting straight out of that band all the way around the lap. Hold the ride height where you want it with a computer, and the aerodynamics stop caring what the car is doing. Mansell and Williams took the 1992 title with it, and it was not close. So the FIA banned active suspension outright for 1994, on cost and on safety, with cornering speeds the stated worry, as part of a wider clear-out of electronic driver aids. This one was killed for working. Subscribe if you want more machines that were far too clever to survive contact with an owner, and next time we will find something with a lot more moving parts than it needed. Send it to the Scrapyard.